Well, hello, good day, good morning, good afternoon, good evening, wherever you are attending the conference, the Euro Global Conference on Climate Change. Welcome to this keynote address, A Path to Net Zero Carbon in the Built Environment. So, before we get started, again, welcome. My name is Azzeddine Oudjehane, and I'm bringing this presentation from SAIT technically, but online. This is a recording, and I'm hoping to join you tomorrow. SAIT, Southern Alberta Institute of Technology, is in Calgary, based out of Calgary, and you can see one of our buildings on campus, School of Construction, where I teach in construction project management. Again, part of our role as post-secondary education trainers is to train students with skill sets, with knowledge in construction, but also create an awareness and sensibility to climate change and sustainability in general. Again, my name is Azzeddine Oudjehane, and my involvement has been in sustainability for the past 20 or so years. I've been involved with board director advisory for the Canadian Green Building Council in the Alberta chapter, and work with government, with industry around the same objectives of bringing sustainability to construction and in general to our life. I'm passionate about that, so as you may have noticed, and being involved in research and development as well as curriculum and partnership. I'd like to acknowledge part of this, and I'm currently in Switzerland after visiting some of our partners in Europe. Again, same goals and objectives globally around sustainability, using different alternatives like what you've heard. I believe an approach to mass timber global towards climate change, right, by Patrick Kraft from Bird Construction. This is kind of the same path. Right? I'll emphasize at the end one proposal or one suggestion or a proposition on how to bring the built environment towards that. But before that, we'll tackle some of the key questions. Why are we here? And what are the trends? What are we doing to face the challenges? Because, we are here primarily because we have a carbon emissions challenge. Before we dive into some of the details on some of the high-level talks, I would like to ask you as an audience, and again, thank you for your participation. I'll have two polls. The first question, do you believe net zero or carbon zero is achievable by 2050? So how are we going to do that? Question is net zero achievable by 2050? You got two ways to do it. You scan the QR code and we'll take you to the poll, or you go to www.menti.com and use the code shown 78658815. So you'll be prompted to enter that code. I'll pause 2 seconds, and it will also have another question in about 10 minutes time, slightly different topic. Okay, and we'll discuss that live tomorrow on Showcase and show you the results in the Q&A. So why are we here? Do we want a planet that is clean, that is still healthy for us to live as population growth by 2030, or do we want a hot planet on fire? Climate change is real. We see the impacts. We have floods around the globe. We have recently was in Pakistan, events that are disrupting and events that we have never seen before, or they keep repeating every year, as opposed to, we used to talk when I was a student. When we did design, we talked about the 100-year flood. Now it's, what's the next drastic, or what's the next event that we're going to face? Fires currently happening, particularly in California. We've seen in all of the summer in Europe, Spain, Portugal, France, and in fact, even in France, fires have reignited because it's been drought and it's been hot. So this is an image, a satellite picture from a Canadian site showing the fires as of August 2022, about a few weeks ago, I guess. Same picture, using NASA satellite image, and you can see the hotspot, the red hotspots for fires across the globe. Well, luckily the desert is yellow, but there's no vegetation there to go on fire. What I find interesting is the fires in the southern hemisphere, that it's not even in summertime, right? So we have a lot of hotspots now in the western side of North America, California in particular, and some even in Western Canada and British Columbia a few weeks ago, that have an impact. And this was 2 years ago, in September 2020. You can see how even in the right picture, the horizon is hazy. Hazy not because it's hot, but because there's snow. We should be seeing mountains there. Look at the difference 2 days later when the wind has brought smoke from California, 1,000 kilometers south of Vancouver Lower Mainland. So this is real and it's happening, and we need to maintain or address the challenge. How can we accelerate decarbonization, right? Worldwide, not just in Canada or Europe or North America, globally. It has to be a common objective that we pursue to stay below the 2 degrees Celsius increase of temperature and hopefully achieve 2050 neutrality, if not negative. How we do that? We know the ways. We need to reduce the use of fossil fuel, and we need to do business differently. The challenge there, getting to 30% reduction of carbon by 2030, carbon not neutral by 2050. We've been talking about it for years now, for decades, and every time we keep pushing the goal. And then, diving a little bit of why we talk about the built environment. Population is growing. Will be 8 billion by 2050, 2060. And in order to sustain living, have homes, have infrastructure, have schools, have offices for all the growth in population, we expect to build 2.5 trillion square feet of projects, new buildings, square feet of infrastructure all over. That's equivalent to 230 billion square meters. What does it be? What is 230 million square meters? The conference was scheduled in Paris, intramuros, although the conference was outside of Paris near Charles de Gaulle Airport. But the 230 million square meters is building one Paris per week for the next 30 years. That's what it translates into. So I'll let you put that into a perspective of building Paris 52 times a year for the next 30 years. That's a big challenge, right? And then that's why we need to be conscientious. And why the built environment? Overall, 39% of global GHGs are due or result from the built environment, 28% from the operation, the maintenance, in other words, heating, cooling, lighting. But the other 11% embodied carbon comes from the material, from cradle to gate. So from the extraction of materials, processing of materials, to the delivery of project, including construction. So that's 11%. Any percentage of carbon that we take off is a valuable input. And then going to carbon footprint, just always like to, that's my educator role, always kind of want to bring everybody to the same level. So what I'm talking about in terms of carbon footprint. It's what individually we do on a daily basis. Going to work, buying groceries, traveling, and so on and so forth. And it's typically measured in carbon, in tons of carbon equivalent metric tons. And so that's where we have an individual role. We all have a carbon footprint. You can see the image here. How can we reduce that? My travel to Europe this time is equivalent to 3 tons of CO2 equivalent. That's a lot. And so I am aware of it, and I try to remain cognitive of what is my impact, because 3 tons of CO2 equivalent, that's more than the carbon footprint that our household has, 2.5 tons approximately for heating and cooling over a full year. So that's less than my footprint just from traveling to Europe this time. So by being conscientious of the carbon footprint I have when I travel, I have to find alternatives. And that's our common goal. How can we all achieve that? Continue our practices, continue to travel or do other activities while reducing our carbon footprint, or at least maintaining to a level that's not going to affect the planet. And again, as an indicator, as a proponent of training, this is how I see the first step, or the first barrier, is creating awareness. We need to train students, our communities, bring that awareness about carbon footprint. Individually, if we all do the same or walk the walk, we'll get to net zero. So that's my first path to net zero, is by giving awareness or creating awareness about the carbon footprint and how to reduce it one way or the other, or finding alternatives. So what are the trends? Globally, I used some examples of large corporation, Microsoft hoping to achieve net carbon negative actually by 2040, and by 2050 offsetting all the emissions put in the atmosphere since the mid 80s, right? How do they do that? By going renewable, by building better, having buildings that are healthy, that have no carbon emissions during construction and no carbon emissions during the operation. So that's a goal. Google maintains or made a statement years ago that they have been actually carbon neutral for the past 10 years. How they achieve that? By using renewable resources, no fossil fuels. So as long as they maintain activities below a certain level, they can achieve that. Our building needs to be healthy. Walmart, and you can see I used kind of a spectrum of businesses from different cores. Walmart goods and services committed to 2040, although the reason I'm using Walmart, they have a path, and because they're tied into how they're driving the businesses, the tied to construction and using and building better. Amazon committed to buying 100,000 vehicles. They're not changing the core of their business. Amazon delivery, they're committing to one day or same day delivery, but they want to reduce the carbon footprint. And then again, it's your conscience about, do you buy from Amazon when they have a delivery? So of course, if you are part of that spectrum, do you go to the store? Do you walk to the store? Do you drive to the store? Do you order Amazon? And those are personal choices, but they are part of our carbon footprint. So can the built environment achieve net zero and carbon zero to some extent? Brings me to my second poll question. So I want you to reflect and give me your opinion on your favorite or your preferred building material, construction material, and based on your country of operation and or your preference, your personal preference. So what is building material? And I'm only giving you three options: concrete, steel, or wood. Three main general building materials, depending on where you are. If you have brick or your preferences for brick or masonry, related to concrete, that's close enough. Okay. How are we going to do that? Again, the question is, what is your preferred building material? You can go to www.menti.com, and the code this time is 66351344, or use the QR code. And I'll bring you the results from the survey tomorrow live on during the presentation. So we talked about the carbon impact or GHG from construction, 39%, 40% globally, CO2 equivalent, 28% from the operation maintenance, 11%. Really, the focus of building better is two cores, right? The focus today is primarily a path towards the embodied carbon, and that 11%. We've been working for many decades. We're looking at energy efficiency of buildings and so on, different standards. we know, or we've learned how to make our building work better, energy efficient. What we have yet to do and put it as part of the standard is measuring the carbon. I know European legislations now are putting stringent standards that by in a year or two, I know talking with colleagues in France as well as in Denmark, what they are building now to current standards, they won't be able to build in 2 or 3 years with new standards of carbon neutrality. If you have chosen concrete as part of your preferred material, you're aware that concrete uses sand, and by 2030 or so, there'll be a shortage of sand to use in concrete manufacturing. And because sand is actually the third natural resources extracted out of the planet after air and water. Well, that's a fact. So bearing in mind that, the other stats or fact that I want to relate, and this came from a report from the UN in 2017 and 2018, the concrete industry produces or emits 8% of the overall GHGs globally. Compare that to the airline industry, and stats from airline industry, I went to check, these were from, I had a 2.5% as of 2020. Granted, it was post-COVID, so, with little airline, but overall, airline industry emits about 2.5%, all sector included. Shipment industry, 5%. So these are interesting numbers. And all these sectors are working towards the path. Talk to innovators. I'm not involved in the airline industry, but I've heard or read a few days ago that Air Canada, one of our largest carriers in Canada, has agreed to purchase 10 or 20 hybrid aircraft, using electrical and probably biofuels, but that's the commitment. Again, we don't want to disrupt the businesses. We just want to find alternative of doing business cleaner in a better way. And that's what we want for the construction industry. Slow steps, but the trends are there. You heard from Bird Construction. In this presentation, I'm using another example, Chandos with a net zero by 2040. The construction sector, when you have leaders like Bird, like Chandos, they also drive their supplier, their subtrade, and I know for Chandos that they committed to net zero by 2040. They will no longer contract or purchase materials from suppliers who, for example, are not committed or don't give their full carbon transparent data. And so that's, again, leadership in big drivers that will bring us to changing the way we do business on a daily basis. Walmart. And I use specifically Walmart, the others I could do similarly, because Walmart has recently committed to building a large campus in southern United States, the campus for headquarters for training. And it's committed to be carbon neutral, using different ways of building, mass timber construction. And so that's the trend we see, building better as we maintain our core businesses. And so, you heard it from Patrick, I'll continue the trend. Wood is trending because it's a green material. You read sometimes that wood is the building material of the future. For those of you who've chosen wood, hopefully that's a confirmation of your choice. This goes about trends, and from Canada to the United States, 400 projects just in the past 3-4 years out of mass timber, slightly different from traditional. I mean, Canada is a country where we use wood in most residential construction. We want to expand that to all type of construction, commercial, industrial, institutional, and so on. So we need to continue doing that. The growth in the United States is much, much bigger. It actually has seen a drastic increase in the past 2-3 years, with 1,300 projects completed or in construction or in design phase, just in the past 2-3 years. You can see, pre-COVID and following COVID. So that's accompanied with the race to build taller with wood. Again, there is a driver for that. The one is showcasing that we can build differently with wood, but it's also demonstrating the feasibility and sustainability wood. So making the case for sustainable construction using wood. Going back home with Brock Commons tall UBC tall building, 18-story, finished in 2018, and then again demonstrated the use of new innovative approaches, glulam, CLT, different way of building, fast, but also with that carbon impact in mind, right? And that's kind of the objective. Continuing my travel globally, the whole building in Vienna, again, mass timber primarily, and it creates a healthy environment. We spent COVID, typically we live indoor for about 90% of our daily life, at least those are the stats for Canada and North America. So our indoor environment has to be healthy. This is, continuing just on the tour here, showing you buildings. I'm sure you've seen others with previous presentations. This one is the tallest building now out of mass timber wood primarily extraction. You can see it's a glass, a wall curtain glass. Building with wood doesn't mean eliminating concrete or steel or glass. It's just finding the compromise, and I'll show you that compromise that we'll achieve from our proposed approach. As you can see, concrete 4 floors, and then the rest is all out of wood. And this is again completed few months ago, I guess, now open. And that's the concept. This is a concept project out of Australia. So that, again, that's the global approach to building differently, building better for a community environment. So to summarize it, why build with wood, taller or small buildings or mid-rise? When I talk to my counterparts across Europe, say, well, we don't like to build taller, and that's fine, but they're driven by sustainability, and wood tends to be the common denominator that drives us to sustainability, to life cycle impact, and then other aspects. So we like to be optimum in our building and the businesses. So that's what we make. So the last few slides, I'm just kind of trying to follow up on how do we make the case for sustainability with wood, right? Like I said, during COVID, we were indoors. We were stuck indoors for all 100% of our time. And so we need to build something that is healthy. And wood is the ideal material for that. Just again, to go back to definitions for understanding carbon, well, earlier I talked about the 11% and the 28%. So the embodied carbon is what we consider to be from the cradle, so from when we extract material to the delivery or project. As you can see in schematics, it's the material, the manufacturing, the construction, building is finished. Now, building is delivered and turns into operation and maintenance carbon. And, how we heat, how we cool. And then, of course, with climate change, we're exposed to the extreme weather changes. So our building have to understand how to be adaptive to that challenge or adaptation to climate change. But that's in the operation maintenance. So again, definition of an operational carbon throughout the life cycle of a building until it is reused, ideally, or recycled for other purposes. And again, we need to have that longer term. We don't want to build for 50 years. That's maybe the culture for North America. We need to build for longer, 100, 200 years, so that building exists, and then we'll have a carbon footprint that will be lower and lower as opposed to increasing. The embodied carbon, however, is there to stay with us because it is what we had put in building. So it is carried through our life of building. And that's why it is important to reduce it. So if you put that in schematic, remember when I talked about the 230 million square meters of construction from now until 2050, The green curve shows shows you the operational carbon, right? And that's increasing. So from 0 when the building opens, and as we build more, that goes on increasingly. The yellow curve shows the embodied carbon that we put at the beginning, which, as I said, remained constant. So based on this example, I'll make suggestions. So if we maintain it, and you can see by 2050, the embodied carbon is 50% or 49% of the actual total GHG from the built environment. So if we reduce that, we'll have done a great job, and I'll show you our approach to that. Just briefly here to showcase or demonstrate, or at least give you an overview of the carbon impact of different materials, from the worst, the bad boy, aluminum, and more or less the good students in lower impact. This is GHG per kilo of material. So why build with wood? Same question. Hopefully, previous presentation had made the case, but I'll hammer it again and emphasize it one more time with our approach. Mass timber, light frame. Why build with wood? Because wood is a carbon sink. Each cubic meter of forest tree means 1 ton of carbon CO2 sequestrated, right? Wood is a carbon sink. So using that same equation, comparing systems, right? If we build with light frame, you've seen an image earlier of light frame versus mass timber CLT. Here's how they compare. They are actually negative. The net carbon emissions are negative for wood systems. Compare that to steel or concrete. Of course, virgin steel being the worst in this case, because it's not recycled steel. So what is the path? How can we get to net zero or carbon zero for the built environment? Suggested awareness. And earlier I showed you the chart showcasing the carbon emissions for between now and 2050, 2060, if we continue in the same trend of construction. And these are assumptions and simulation. So in orange, on the top, you have the operational carbon. And then in the yellow, we have the embodied carbon. So one thing that you may notice is that the embodied carbon is actually negative. So if we manage to have negative at zero, T0, when building is open, that's maintained constant. And by the time we reach 2050, the offset of the emissions from the operation and the maintenance will be offset by embodied carbon. And that's how we achieve carbon neutrality or negative carbon. Of course, this is simulation, but if we start building with that in mind, we can certainly do it. The main goal is, 1, achieve carbon negative at the start, at the end, at the gates, or from cradle to gate. If the carbon emissions are 0 or negative, we can certainly do better towards 2050, at least. We did some work at SAIT with some students looking at, making the case, right? We have to make the case, the business case, sustainable case for people to invest and build. So we did a 10-story building, for example, compared to traditional extraction concrete versus that of CLT. A 10-story for Calgary would be equivalent to, as you can see here, roughly 390 trees out of a sustainable forest, managed forest. Now, of course, the question, yes, we can do that in Canada. And I'm always asked in various of my talks, how about the rest of the world? Well, the Southern Hemisphere, where there are no trees, Sub-Sahara, although, we can always share innovation, but we can, and that's the pattern, is how can we innovate using the same approach to use local materials that we know how to build better, and how can we achieve that carbon zero? Again, because ultimately, and this is using data from Calgary. This would be, in fact, your operational carbon, the second part. Comparing traditional to wood was about the same. Yes, concrete building performed slightly better, but overall, you can see with the same building envelope, etc. The key in the operational carbon is the source of the heat and energy that we use. If it's renewable, we're good. We even achieve faster zero carbon. Some environmental facts here, but if we take that 10-story building, this is 2,300 tons of carbon taken off or not emitted, because we build out of CLT and mass timber as opposed to concrete. And so we looked at traditional, we're using light rain. What would be the impact? Again, in terms of emissions that we're withholding, we're not emitting by using this method. We use smaller scale buildings, 6-story. Again, simulation just to see what would be the impact. In this case, savings is about 77 cars per year, right? Equivalent to taking them off the roads. We use the mass timber approach for the same building, same square footage, same building. Where we got nearly 155 cars, so twice more, because we use massive wood in this case. And so this is kind of the approach. If we can make each building, each new project, a certain measure carbon, then we can look at alternatives. So this brings me towards the end of my talk. Is the built environment, or can the built environment achieve carbon zero by 2050? Yes, that's my belief, and that's an approach that will continue using mass timber. It has other benefits. You probably heard of them, but substantially, it's the carbon footprint. Again, thank you for your attention. I'll be happy to entertain questions, but if you want to reach out at the conference, you have my email. I'll be happy to talk further with you. Thank you again for your attention, and look forward to your